Hello world, it's Calcutron here with another TI basic tutorial. In this episode we're going to be learning about a new control flow command called menu. So let's get right into it and create our new program, and we'll call our program menu appropriately. So menu, the command, can be found in the control flow menu, and it is option C. Now you probably knew that you can use your numpad 0 through 9 in order to select things like label and go to. So if I hit 9 on my keypad while I'm in this menu, I get the label command. Now if you just hit C on your keyboard, or the character corresponding with alpha C, the program key in this case, you won't get the menu command. But if you hit alpha first and then C, you can pull out the menu command much faster. Otherwise, you'd have to hit the down arrow 12 times or hit the up arrow almost as many times. So this command is going to allow us to create good-looking menus like the ones we've already seen in this episode and we've been using since day one. So these are menus like the program menu. And you see when we hit program, we get this menu with 3 screens and a lot of options on these screens. So we'll be able to emulate this behavior a little bit, but with some restrictions. So we're actually not able to have more than 7 options in our menu, and we're not able to have multiple columns of our menu. But what we can do is have a custom menu with whatever titles and whatever prompts that we want. So the way we do this is we use this menu command, and the first argument we're going to pass to it is the title of the menu. So I'll just give it a generic title, and then separated by commas are going to be pairs that represent an option in the menu. So the first thing in that pair is going to be the string to display associated with that option, and then the second thing in that pair is going to be what to do when the user selects that option, and that's going to be represented with a label. So we'll use the identifier of our label. So this is the thing that we would put after our label, or we would put after our go-to in order to get to that label. So we're going to create a label A1, and we can go ahead and create it now. Label A1. And now this menu, if you select option A, is going to jump execution to this label A1. And of course it wouldn't be much of a menu if you only had one option. So we can give it multiple menu options by separating pairs by commas. So you can actually only have an odd number of inputs to, or arguments to, this menu command, because you'll have the title, which gives you 1, and then you'll have multiples of 2 for all of the options, because you need, again, what to display associated with that option, as well as where to jump to if the user selects that option. So let's go ahead and create 2 more options in our menu. So option B, and we'll link that to B2, and then option C, and we'll link that to C3. And then, of course, we're going to have to go in and put these labels into our code. So label C3, and then label B2. So now that we have these labels in our code, when we execute this, if we select menu option B, or if the user selects menu option B, then it's going to jump to label B2. So when it jumps, we're going to want to have it do something, and later that can be a more complicated action depending on what your needs are, what the needs of your program is. But for now, we're just going to have it display A1, B2, and C3 so that we know exactly where did it jump to. So now if we run this, we can see our nice custom menu with our own title and options A, B, and C. And we can change the name of these options to anything we want as long as it fits on the screen. So it doesn't have to be option A. It could be easy, medium, and hard, which is one of the most common uses of menus to select a difficulty. Or it could be the start menu of your program. So your options could be start, load, and quit. Or it could be something entirely different. So now if we go ahead, we can use our up and down arrow keys just as you're used to. And if we select option C, we see it jumped to label C3 and it output C3 on the next line. Now, if we do option B, we're going to notice two pretty interesting things. So first, the C3 from our last execution of menu stayed on the screen. Even though our menu was taking up the whole screen, the home screen was preserved. And then secondly, that when we ran this, after displaying B2, it also displayed C3. Now if we run this again, after we pick our menu item, the screen will remain the same as before we picked it. So if you pick A, everything that was on the screen before remained there, and then we added a couple new things to the screen, A1, B2, and C3. So it's displaying all three, and let's go check out why that's happening. And so here we are. When we select option A1, it's going to jump to this label A1 and display A1. That's a lot of A1s. It's going to display A1, and then it's going to keep on executing the program. So it's going to go, it's going to read this label B2 statement, and it's not going to do anything. And then it's going to display B2. So it's going to keep going through the code, even though you might only want it to have displayed A1 when we select A1 and not have displayed B2 and C3. It's still displaying them because after it displays A1, it just keeps going. So there's something we can do about this, and that would be to add in another label and then to jump to that label after we've done our display. So after we've displayed A1, we want to jump to label E. So let's put our goto in here. And this solves the problem of fall through. So that's what it's called when, after finishing the code associated with executing one menu item, it falls through and executes the code associated with the next menu item. And in this case, I'm going to say that we don't want it to fall through, and we want it to go immediately to the end. Now, after our code for C3, we could have it jump to our label E, E for end. We could do this, but you'll notice that this is unnecessary. It's redundant because we're just going to go straight to label E anyways right after displaying C3, so we can take out this goto. Now, when we run this and we select option A this time, we just get A1. We select option B this time, we just get B2. We select option C this time, we just get C3. So it's not falling through into executing the code for the other menu options. Now this is pretty interesting. We're able to selectively run code with our menu, but oftentimes we want a different behavior, and what we want is for selecting a menu option to select a value for one of our variables. So let's say that this was the difficulty menu in a game, and let's go ahead and change this to a difficulty menu. So we'll change this prompt string to easy, and we'll have it jumped to still label A, and we'll change this one to medium, Oof, really struggling with the typing today. And then we're going to have this one jump to label B, and then we're going to have this one jump to hard, or this one be our hard option, and it's going to go to label C. And now, what we could do, which would be a fairly easy fix for this program to make it select our difficulty value, is we could just change these, instead of displaying A1, to be display. That's not display. And we don't actually want display. We could change it to being a store. So if we want easy to correspond to a value of 1 in our variable D for difficulty, we can have 1 stored in D. And then very straightforward, we can, if it goes to label B, we can have it store 2 into D. 2 into D. And then if they select hard, which is label C, we can have it store 3 into D. So this is the same thing that we were doing before. We're just storing into a variable instead of displaying something. And now we can check what is D, and it's 1. Let's go ahead and have it display D. Display D, and now if we run it, and we select medium, it displays 2. If we select medium again, it displays 2 again. If we select hard, it displays 3, and easy, it displays 1. So it looks like we have a functioning difficulty selector. However, we can optimize this. And when I say optimize, almost all the time, I'm going to be meaning optimize for space. So your calculator has a limited amount of storage on it, a limited amount of memory in which you can store your programs. And if you want to check how much memory each program is taking up, and how much memory you have left, you can hit second and plus and go to the memory screen. This is also where you would delete and archive programs, and if you hit 2 and then 7, and the 7th item is the program, you can see all the programs you've created and exactly how much space does each program take up. So our menu program, the one that we're just editing, takes up 83 somethings, and that's 83 bytes. And don't worry if you don't know what a byte means. It's just a unit of storage, and each character in your program takes up about a byte, or each command in your program takes up about a byte. So if you had a program that just consisted of one number with 83 digits, then that program would take up 83 bytes plus some more bytes for other things. But our program takes up 83 bytes for our menu command and all the characters in the strings and our store characters. So it's storing all that inside the calculator, and it's taking up 83 bytes. Now, 83 bytes might not sound like a lot to you, but if you consider that our calculator only has 23,000 bytes on it, it actually takes up a considerable amount for such a small program. And again, when you consider how much memory any desktop computer or even your smartphone has, it's probably in the gigabytes, or maybe if you have a high-end computer, it's measured in terabytes, or if you're using some industrial storage device, you might have petabytes. So when we think our calculator only has kilobytes, thousands of bytes, whereas a giga, which I'm sure whatever device you're watching this video on has at least a gigabyte of storage. In fact, this video probably takes up more than a gigabyte of storage. You'll know that 23 kilobytes is really not very much, because 23 kilobytes is about 1,000,000 times less than 23 gigabytes. So this is at least 1,000,000 times smaller than the amount of data in the video you're watching this on. So I hope that demonstrates to you that the calculator has very limited memory, and we can only write about 2,300 of these menu programs before we run out of memory. So what we often like to do in TI Basic, because these calculators have such strict memory limitations, and we often like to write big programs and like to have lots of programs on our calculator, what we like to do is we like to optimize our programs to be as small as possible. So one way that we can do that here is to use the fall-through to our advantage. So currently we're resisting the natural tendency of these labels to fall through using this go-to-e. Now we're going to take out this go-to-e, and you'll notice if we were to just take it out and not do anything, while we have reduced the size of our program, it's complete garbage. It doesn't do anything useful now, because it's always selecting 3 into D. Even if label A is selected, D will become 1 and then D will become 2. But no matter what happens in this program, 3 will be stored into D on this line. So if we want to embrace this fall through and save a byte or two along the way, what we can do is pre-initialize the value that we want to store a number in. So we want the default value to be 1, or our lowest value of D. So now we can actually take out this label A, and by default D will be 1, and then we want to move this label A down to the bottom, label A, and we're actually going to shuffle the order of this again to be C, and then B, and then A. So what we can do is, instead of storing a new value into storing a new value into D, which stands for difficulty, what we could instead do is modify the value of D that we already have. So at label A, if they select easy, D is already going to be 1 because we pre-initialized it to 1. So we're done. We don't want to change D anymore after that, and we can just go straight to displaying it. Now, if they select label B, if they select medium, D is going to be 1 at this point, and so we want to increment D by 1. So we're going to do D plus 1 stored in D. Now, here's the tricky thing. For label C, we're also going to have it increment D by 1, so that when it falls through into this B code, where B thinks D is already 1, and so it's going to increment it to 2, well, if D is already 2, it's going to increment it to 3. So when we select C, it's going to run through the most of these increment statements before it gets to the display. So if we select label C, it's going to do D plus 1 stored in D once, and D will be 2, and then it's going to do it again, and D will be 3. Now, if we wanted to add more options to this menu, we would just put them at the beginning. So let's say another label D, and that would be, we could add another option called insane mode, or if you want it to be more than hard. And now D would be incremented 3 times if you selected label D. So let's go ahead and try this out and verify that it works as I've just described. So I select easy, it's going to skip all the increments. A will be 1. If we select medium, it's going to do it twice. Hard 3 times, and insane, it will increment it 3 times, becoming 4. So that's one of the most common ways to use a menu, is to take advantage of this fall through, save a couple bytes, and still be able to select a value into a variable. And you should note that you don't have to always increment your variable, so it doesn't have to be D plus 1, and they don't all have to do the same thing. So you can do D plus 2 for the insane mode, and when you select insane, now it's going to be 5, whereas hard will just be 3, so it's a bigger jump in difficulty, whatever that would mean in your application. So let's go ahead and remove this insane part of our program so that we can go take another look at the size of our program. And while we're on the topic of optimizing for size, we can actually take out this display, and this is something I showed early in this tutorial series, is that if the last line of your program is an expression, so just putting a variable identifier D all by itself is actually an expression, it's going to display the result of that expression upon your program terminating. So if you end your program with just a D, it's going to display that D instead of the usual done message that you see. So let me actually put back the display, and we can just notice the done message. So we do our menu, we select hard, and after it displays 3, it displays done. So if we instead put just D, the expression D, which evaluates to whatever value D has in it, if we put just that and we run our menu program, it doesn't actually display the done message, and in its place it displays the value of the expression executed on the previous line. So we just optimized further, and we took out our display statement, so it's slightly smaller. So now if we check the amount of memory that we used, we saved 6 bytes doing that optimization. So whether or not you think that our current implementation is better to read is up to you, and if you think that the way we had it first is better to read and you don't care about saving 5 or 6 bytes on your calculator, you can do it any way you want. But I just want to introduce to you guys the idea of optimizing your program for size and the idea that these calculators have very limited memory. I hope you got a little taste of how you might go about doing that in this simple example of the menu program. I also hope that you learned about making your own custom menus with your own title and your own prompts, and maybe later we'll make our own even more custom menus, and we'll actually program all the code to display the titles of the menu and the different options. But until then, we're probably going to be using this menu command, and it's pretty useful. So anyways, I hope you learned about program storage and the menu command in this episode. And if you have any questions or comments, please don't hesitate to leave them below. Bye-bye.